All right, so this is going to be kind of a fun video. It's going to be a QA video where we're just going to hang out for a bit, talk about a few different things, and visit some websites and talk about where you can find resources to learn and become a better 3D artist, perhaps, or even think about maybe becoming like a technical artist or something like that as well. So we're going to start here with kind of the background of why I'm doing this video. There's a guy that's just getting into Blender, and he has a lot of like really low-level questions as it relates to creating 3D models, like, you know, what is a bake and how does a model store texture information and all this other fun stuff. And it's just a lot of low-level stuff like that. And his idea is that the more you understand about things fundamentally, the better off you'll be when learning how to do 3D models. And truthfully, yeah, there's some truth to that. You know, the more you know, the better off you are, right? But let's just go over to Cube real quick, and we'll delete the camera and all this other fun stuff in the scene. So when you look at the Cube, you don't think much about it. But remember, your models are made up out of different little things, right? One of the most important being the vertex, and it's just a dot of information. But a dot of information, such as a vertex, can store additional information along with it. Not only is it just a point in space, and if you press N, it's a location as well. It has a direction to it, possibly, okay? You can store color information on it. So there's all kinds of fun low-level stuff like that, right? And if we were to take a look at the cube and go over to the GeoNodes tab, you'll see there's multiple vertices and they're in an order. So 0 through 7 here, and they have all of their locations recorded like so. On top of this, though, is another fun little fact. You go to your object data properties and you take a look under UV map. It has a UV map as well. So let's just delete this real quick and take this cube. We're going to export it out to the desktop as an OBJ file. And I already have one out here, but I'm going to replace it. So we're just going to leave it untitled OBJ. Default settings here for the export, nothing special. All right. And so we can go to our desktop, and you'll see we had two files come out. One is an OBJ file, one is an MTL. You can actually open both of these with Notepad. So choose another app if you need to. Use Notepad, maybe just once. And you can see you can't open that MTL file, and there's some information here, but you can do that with the OBJ file as well. So when you open the OBJ file up, you're going to see a list of vertices right here, okay? And take a look at this. There's also vertex normals right here, among other things in here as well, some other information for the faces, right? And use MTL, made in Blender and whatnot like that. So there's all kinds of data that could be recorded into an OBJ file. And whenever you record data, you can think of that as something like baking, okay? Static information that doesn't change is usually basically what you do when you bake information, basically. It's not always just about baking an image, it's baking information. So like any kind of vertex position, reference point, you can add data to this file and potentially use it. Matter of fact, when you create certain types of images for like Facebook or something, or like YouTube, and you have to have like the 360 VR kind of setup going, you actually have to add information to your file in order to have the website use it accordingly so that it knows to display a 360 panorama photo or whatever. And there's a little code or snippet that you can get from whatever website that you would want to do that on. So just something to think about now. But yeah, if you were to go back, let's just move that off to the side. And let's say we add the UV map back to it. Let's go ahead and unwrap this thing with unwrap smart UV project for now. All right. And if we were to export this back out as a OBJ, we'll send it right there to replace our object. We'll go ahead and reopen that with Notepad, and you'll see now we got a lot more information going on in here. And that's your UV maps, guys. That's what it's recorded. It's a 2D values, basically. So like 2 vectors, and you got 3 vectors up here, something like that anyways. So that's what that is, all right? If you were to Control Tab with your object, go into Vertex Paint, and let's just say we paint red. You notice the values here, 1, 1, and 0.9, or whatever that is. Let's just do, press X. We'll paint it red. Go back to object mode. You see you can't see it unless you go to your view here and change it from material to attribute. Okay. So now what's happening is when we export this, you'll see something a little bit different. Go ahead and open that up now again. And it should have took effect. Maybe it didn't. Oh, it didn't. You know why? This is why. Let me show you. I did not check colors here. So it didn't record the information at all. So nothing changed. We check colors and we do that again and open it up. Ah, there we go. You see the difference? Maybe it's added that information onto that vertex. There you go. So that's what it's doing. And so software like Blender, 3D Studio, or whatever the case, when you're importing a file, a lot of times, OBJ is really easy to understand because you can open it with Notepad. But if it's like an FBX file, which is made by Autodesk or whatever the case, they're basically listing things out like this. And the software is looking for this type of information with the importer that it has set up. So like when you import a file, right? It's going to use that algorithm, or not the algorithm, but like the layout in order to understand what's going on there. And so geometry nodes, this is where a lot of guys really go wrong with geometry nodes, because when you look at that, it probably doesn't make sense at first what's going on. But when you create like a geometry node setup, you know, you can do all kinds of fun stuff in here with geonodes, of course. But one of the main ones I just want to point out is the very start of all of that, which is going to be some of these things. You have constants, right? And you'll see there's booleans, there's colors, there's images, materials, strings, values, and vectors, and all kinds of other fun stuff like that. But there's all kinds of inputs you can use, basically. So right here's another list. That's easier. Press it and go to the side panel. Strings, booleans, vectors, integers, floats, you name it, right? So it's all in here. And that is very confusing, I think, when you're a beginner and you're watching any kind of tutorial, especially the GeoNodes tutorials. It's like, how do these people come up with all this stuff? What are they doing? Like, how do they learn this? And that's where we're going to go to the web, because there's actually places to learn how to do this somewhat effectively and for free and by very well-known institutions. And so one of those little courses you're going to want to look up is CS50X. It's a basic computer science course from Harvard. Okay. And it's going to be under their edX section here. I think this is like a cheat sheet, actually, what we're just loaded up. But we'll have to kind of browse around until we can find the basic idea here. Yeah, you can enroll in this at any time. They update it every year, basically. It's a computer science course, guys. And this is going to teach you the basics of how computers work, basics of programming, and that's pretty much all you're going to learn in it, right? Like, it's going to go through that. It takes about 12 weeks or so. So if you want to sign up and, do this, you can do this. If you want a certificate for it, you can actually pay to get it, a certificate for it. You can put it in your CV or something. It might look kind of good if you're trying to get into somewhere to work, that's a possibility. Now, I wouldn't say most courses, especially free courses, a certificate would be worth it, but this might be one you would want to consider doing, because most places aren't as well known, perhaps. This just might look a little bit better on your CV, like I was saying. So, if you want to learn this, learn this. And then eventually you'll find yourself working with game engines, obviously, right? So game engines and Blender on top of that, and a lot of other things, they have what's called an API. And so when you are looking for information on programming, usually you focus on the API a lot of times. You got all kinds of just fun stuff in here. You got constants and this and that and this and that. You see, and it takes forever to load, apparently. If it loads, let's refresh. Maybe it'll load. Oh, 404. We can't access this API. It's too high class. All right. Well, anyways, whenever you're working with game engines or you're programming something, an API can be helpful. It might help you out quite a bit. Lots of stuff to look up. I mean, literally lots of stuff to look up. This is classes, I think, right? So it's like, it just goes on and on and on. So as you're learning 3D and you're in software like Blender, it's not really necessarily required to understand this like right off the bat. You'll kind of get introduced to these ideas of like the computer science things slowly as you pick up more and more artwork. But it's not really that you're required 100% to know all of it. Just understanding like those are the basic ideas of your model, right? Like your UV map is a flat image. It's only, two coordinates, whereas like the 3D model itself is 3D, 2D. Get it? Yeah. Um, and so on and so forth. So when you're modeling and you're trying to figure out like what's what and so forth, it's really not that you don't have to understand the absolute core of it, because you start getting into a weird territory. Like the more you dig deeper, you're getting into like low levels of information. Like a Bezier curve, for example, is, this is mathematically generated. And if you absolutely want to know how a Bezier works, there are websites all over the place that will help you learn this stuff. Like we can go look up a Bezier curve formula and we can go check this out. There's a Bezier curve whole section on Wikipedia. We can go look all this stuff up. I mean, this is fun stuff here. You want to set this up, go for it. Not the hardest thing to do, perhaps, once you start to understand it. But when you're worried about art and you're worried about like color theory and other stuff, this probably isn't what you need to be learning, right? So the low level stuff doesn't really matter as much. Like you're not creating a render engine. You're not creating, you're not trying to figure out how to render a triangle with shading on it and UVs. That gets into another part of working with computer programs, 3D programs that as an artist, you don't really need necessarily, until you start maybe getting more into like tech art. Okay. Tech art is when you can program and do artwork, or you can create art tools out of programming or whatever. So you get where I'm going with this. You don't need to know all that. That's what I'm saying. But it could be useful to understand this if it interests you. You have to always remember, like, I have no interest in this. This is my personal preference, right? I guess I don't really want to spend time learning how to set up Bezier curves and as an add-on in Blender or something like that. But that's where, scripting comes into play. You have different types of programming. Obviously, there's like C++, and then there's C#, and then there's Python, which is what Blender is based off of C++ and Python. But the scripting part of it is all going to be Python for the most part. And you can see Python, blam. You got all these examples of code here. And it's really, once you start to, play around with these basics ideas of starting up the code, and you can make things happen like relatively easily. It's interesting. Even you can sort of, let me give you a basic example. Think of like every time you do something in software, it has to go through a bunch of lines of code. So if let's say I select this face here and I inset it. And as soon as I inset it, you can see it recorded some information down here, right? That's what it's done. And then let's say I extrude it after, okay? And then look at what an extrude looks like. This is crazy, right? So inset simple, extrude not so simple. But the main idea is I just did these things. And so if I was to, I don't know if I got to set up BPY for this, but I might. Hold on. We'll find out in a second. I should be able to copy this, do a new script, and I'm pretty sure I'm going to have to set up BPY for it. You can see we got these two different things going on now, right? But if I grab another face and I hit play, okay, yeah, it's not going to. You got to do import BPY. I think it's just import.bpy. I don't know. I don't do this a whole lot, but every now and then I find myself in here trying to mess around with it. Okay, no, that's the wrong one. Let's do a template real quick. Just any template I think should work. Or not any template should work. Yikes. That's all I want. Import.py. That's all I'm looking for. I just forgot what it was. Oh, it was right. It needs like a space or something. I should be able to select the face and hit play, and it should, do the same thing basically. But you can see the extrude actually went down the other way. So it didn't quite work out the same way. Normally the one I was using, sometimes I want to like inset windows all at the same size, and I want to make different kind of selections and stuff. So what I'll do is I'll inset again and hold control. We can toss all that. And now we can just copy And sometimes I have to fiddle with this to get it right, but should be able to select any other face and just hit the play button and boom, you see? So I can repeat that process over and over. It's kind of like setting up an action in like Photoshop, for example, except you have to use the scripting language to do it, right? It's really kind of simple if you want to do really simple things like that, where you can easily copy something like this over, paste it in. It's a lot of fun, really simple. So, but here's the thing. If you don't understand any like basic computer science stuff, this becomes harder, right? Like, what's a Boolean? What's an integer? What's a constant? What's a string? Like all those things don't make sense to you, but that's where you learn all that in your computer science class. When it comes to art, you're worried about things like shapes and form and harmony and design and all this other fun stuff, balance, contrast. And that's a whole different animal. It really is. So when you're thinking like you want to become an expert 3D modeler and you want to become an awesome artist, don't worry so much on the technical things. Worry not on those technical things anyways. Like there's technicality to color theory, obviously, but just focus on reproducing shapes, forms, developing like story elements, good design fundamentals, art fundamentals. All of that's going to help you out tremendously. There's so much to learn in that alone that, like, especially if you're throwing animation into that, because now you're talking about animation is like something like performance art, right? You have to be able to like convey with motion alone, perhaps in a character, you should be able to convey different kinds of personalities and all kinds of other fun stuff if you're doing people. And so, that takes a lot of time and effort to master if you're just doing it by hand, right? You got to learn about keying and rigging and all kinds of other fun stuff too. And yeah, the computer science side of it, useful, obviously. You'll be able to start making scripts potentially, and then you'll be able to add in, like you can modify parts of Blender. You can add little menus and stuff and whatnot with the scripts you set up and how you can create like the basis of an add-on. You can actually make an add-on entry relatively easily to, have your little scripts show up here in the add-on section. But it takes time to learn the basics, right? Like you don't want to just jump into scripting with no kind of education beforehand. It's like you need to learn addition and subtraction before you go off trying to do algebra, right? And that's the basic idea there. And then once you can start doing algebra and you understand that process, then now you're ready for everything else that you're going to run into, or, you're prepped to get into more advanced stuff like physics and whatnot. But it's a learning process. It's like you start here, you get there, then you get there. And even in the arts, not just like the programming side of things, you're going to find that like the very start of when you're getting into like 3D modeling or drawing or art or whatever, like you're going to have the Dunning-Kruger effect take effect, right? And you guys don't know what I'm talking about here. That Dunning-Kruger effect looks something like one of these graphs here, where when you first start, you're super confident in what you can do. As you realize you're not maybe knowing as much as you should, you get it kind of like this depression, basically. And then you go back up. This is misleading. You don't go up at like a steady curve always. Sometimes you go up a little and you flatline, and then you have a super quick jump up, and then you flatline again, and you have these walls or these hurdles you run into. And every time you're trying to advance yourself as an artist, you'll start to feel the drag. You'll start to understand like, I'm not advancing. I'm not moving forward. Something's wrong. And you have to figure out like what you're trying to get over, like what is holding you up there. And you'll get back up over that hurdle and then move on and become a better and better artist too. So it could be something like a lot of times you might get somewhere and you kind of flatline and you realize you went too far and you had to learn something back here. So like you might have like forgot some of the art fundamentals. You might have forgot design fundamentals. You might have forgot like, you need to learn rigging to do animating, or you haven't practiced enough going from Blender into like a game environment, like Unreal Engine or whatever. And so you thought you were doing really good with modeling and texturing and all that other fun stuff. But then all of a sudden you realize I don't know nothing about optimization and how to make that work out. And then you're back to, learning more about modeling, or maybe you're doing baking, right? And baking is one of those other things that can really mess you up as a beginner, because you just don't know, certain models don't bake well if you don't model them well. So it's kind of one of those things. But baking's interesting. So if we want to take, I'm just going to create 2 UV spheres real quick, just as a rough idea. No, 2 UV spheres. I'm just going to talk about baking real quick. We'll go down to 8 and 16. Right. So when you look at a surface, like maybe this one's even higher resolution. I'm just going to subdivide it, even though it's not good to do that to a UV sphere. But you're looking at a surface like this, and your high resolution is going to be much finer, obviously. And then your low resolution is going to be something like this. And so we know that our UVs are going to end up laying out flat, right? And all that's going to happen is you're going to have, usually you have what's called a cage, and most software generates an automatic cage that kind of expands outwards. So you could think of it as like a duplicate of your low, and it's going to it's going to expand, maybe even out evenly, something like so. So you have this cage with your low with the high, and these two here, the vertices have the same numbers, so they can actually trace back to each other. And that's just one way that might occur. And they're usually created along the direction between the two. All right. And then the vertex normals get mixed into all this, and it all gets interpolated together. And then you also have ray casts that are sometimes done at like the pixel levels. I think it's pixel level anyways, or it's interpolated between the vertices anyways. But this would be like a fragment shader that does every pixel, whereas like some software uses vertex for the calculation for the shading and the normals and all that. And so this is getting into like lower level territory that as a beginner, you don't maybe necessarily need to know off the bat entirely, not exactly how it works, but you'll see a checkbox in like substance, right, when you're using it. And let me just launch up substance real quick just to prove a point, I guess. And so from my understanding, someone said Blender's vertex shading, but also the trick is that I've always known it as a fragment shader. So I don't know what's what now. I got confused somewhere along the line, but compute tangent space per fragment. See, that's per pixel basically. With that off, it'd be per vertex. And so that's the tangent space. That has to do with your shading. Okay. Tangent space on a normal map, for example. And that's going to be MIC-T shading. So if you ever want to look these kinds of things up, this is once again getting into low level stuff. And MIC-T, I believe, is just open, so anybody can go look at it. And it's something that Unreal, Unity, everything uses it just about. You can see VNT is the tangent space normal, basically, right? So the quad caveat, and they just got some interesting stuff to read here on this website. Control middle mouse, by the way, can zoom websites in and out. So anyways, yeah, so there's a bunch of stuff to look up for MIC-T, and take CS50X, have some fun. I don't know all the answers to everything, honestly. I'm not Google. There's definitely people that are better experts in the programming side of things than me, and even GeoNodes, obviously. But the thing is, you can learn it if you want. It's right there. It's available for you. There's all kinds of resources and references online. You can Google things. You can find research documents, papers. You can find theses of someone's doctorate degree on some college website, probably, on how to better interpolate quads or something. I don't know. There's always something out there like to learn. There's tons of information. Trying to, like this is like step one is just even knowing it exists. The next step is learning a little bit of it and then starting to decipher your way through like the information spider web out there and trying to figure out what interests you the most, maybe if you're into the tech art side of things anyways. And hey, if you are, you'll do well in the game industry for sure. It's, people always need better tools and software and everything else. And yeah, so that's that anyway. So that, yeah, you guys have been doing art for a while. You probably already know, you don't need to know all this. Just kind of an interesting conversation maybe, but personally, I hardly touch programming. It's just, I never need it really for the most part. I'll do some light scripting, like C++. I don't really do, but you know, a little bit of C#, Python. I'm kind of getting into because of Blender, but that's it. But otherwise, I'm in like blueprints with Unreal Engine, and you already know how that goes. Visual coding, if you would. Like Unreal Engine's blueprints or even geometry nodes is sort of like visual programming. That's what it basically is. The only difference here is that you can use, obviously, Blender's resources available to like add cubes and other fun things. And you got to remember, even something as simple as like adding a cube, like building a cube, if you were to set that up in Python or whatever the case, right? Like you can do that if you really had to. So you can build a cube in Python if you wanted to, or you know, just make little simple scripts. They stay there. You could save these things out, so on and so forth. Anyways, yes, I thought it was just going to be a fun video to talk about this because a lot of guys don't really fully grasp like the art and digital art anyways. Like the computer science side of it mixes with the art. It's helpful to know both, but it's a lot of information to take on. Like, you know, think about like a car, you know, most of us probably have never taken a car apart to understand how every little facet of a car works, right? But we drive them. We go to work in them or whatever. But maybe some of us have gone a little bit extra and took apart a lawnmower engine or worked on some go-karts or something. But most of us haven't probably ripped apart a combustion engine from a Toyota per se. Some of you probably have, but a lot of us probably haven't. So I know I haven't. So good odd chance some of you haven't. Anyways, interesting, kind of, sort of. Maybe it helps you out in some way. I don't know. If you did, leave a like, subscribe, all that fun stuff. Hey, if you are a programmer and you want to toss some information down at the end in the comments section, go ahead and do that. I think it'd be kind of interesting for some other people to read that stuff. So see you in the next one. All right. Take care.